Ever wonder how Spotify just knows your playlists instantly, or how Amazon keeps stuff in your cart even if you walk away for days? Well, it's not magic, I promise you. It's all thanks to a hidden blueprint, this invisible structure that holds everything together. And today, we're going to pull back that curtain and really dig into the art of database design.
Look, think about it this way. You would never, ever build a skyscraper without a blueprint, right? You need a super detailed plan to make sure it's strong, organized, and, it doesn't fall over. Designing a database is exactly the same idea. We're going to be data architects, carefully planning out a structure to hold information not just safely, but in a way that makes it easy and fast to use. All right, to make this all real, let's ground it in a problem. Let's meet TechTrade, a small electronics company. Right now, their whole business is basically drowning in a mountain of paperwork, and it is getting messy. They are desperate for a better way to handle all their info.
I mean, just try to imagine the chaos here. Customer files are stuffed in one cabinet, invoices are all tracked by hand, the inventory? Oh, that's on a spreadsheet that's probably out of date 5 minutes after it's saved. Want to figure out which employees sold what or which supplier to call for a certain part? Good luck. It's slow, it's full of mistakes, and there's no way they can grow like this. This is the exact kind of mess our data architect is here to clean up.
So where does our app architect even begin? You might think it's with a bunch of complicated code, but nope. It all starts with a simple sketch. This first step is called the conceptual design. It's just a high-level, visual plan that gets everyone on the same page about what information we need to store and, this is the important part, how it all connects. And here it is, that first sketch. It's called an Entity Relationship Diagram, or ERD for short. Now I know, this looks a little intense, but don't worry. It's really just a visual map of the business. It shows us all the key things we need to keep track of and how they all talk to each other. Let's just break down its three main parts to make some sense of it all.
First up, we've got entities. An entity is just any key person, place, or thing that we need to store information about. The easiest way to think about them? They're the main nouns in our system. So in this diagram, you see those rectangles labeled employee and project? Yep, those are entities. Simple as that. Okay, so if entities are our nouns, then every entity has attributes. These are just the specific details about that entity. Think of them as the adjectives that describe our noun. You see those ovals connected to the employee entity, like name, address, and birth date? Those are all attributes. They're the actual bits of information we're going to store.
And finally, we have relationships. These are the verbs that connect our nouns, showing exactly how two entities interact with each other. That diamond shape right there tells us that an employee works on a project. So, see, when you put it all together, this diagram just tells a story. Nouns, adjectives, and verbs. It's kind of like grammar, but for data.
Okay, our architect has the conceptual sketch. Now it's time to turn that drawing into a more detailed, technical floor plan. This phase is called the logical design, and this is where we get one step closer to actually building this thing.
All right, this is where the magic really starts to happen. On the left, you see our visual ERD sketch. And on the right, we see how that gets translated into something called a relational model. Just notice how all those entities and attributes are now organized into these really clean, structured tables. This is the format a computer can actually understand.
This relational model is basically the heart of almost every modern database. It organizes all our information into simple tables, with rows and columns, kind of like a superpowered spreadsheet. This highly structured format is what lets us store, find, and connect information with incredible speed and accuracy.
But wait, before we can start building, there's one more really critical concept we got to talk about. Keys. Think about it. In a giant building, every single room needs a unique number so you can find it, right? It's the exact same thing in a database with millions of records. Every single entry needs a unique identifier, or a key, so we can pinpoint it without any confusion.
But sometimes, just one piece of information isn't enough to be unique. That's where a composite key comes in. It's when you combine two or more pieces of info that, together, create a single unique ID. Now, a compound key is just a special, extra clever type of composite key where each of its parts also happens to be a key that links to another table, so it's a key that's doing double duty.
Let's make that totally clear. For a composite key, just imagine booking a flight. The seat number 14A isn't unique by itself. I mean, hundreds of planes have a seat 14A, but the combination of flight number UA452 and seat 14A, boom, that is absolutely 100% unique. That's a composite key in action.
And for a compound key, check this out.
Say we want to track the hours an employee works on a specific project. We can combine their employee ID and the project ID. Now here's the really clever part. Each of those IDs also acts as a link, pointing back to the main employees table and the projects table. So this one key does two jobs at once. It uniquely identifies that specific work entry, and it connects all our tables together. Pretty smart, huh?
Okay, the blueprint is done. The keys are all defined. Now it's finally time to pick up the tools and start building. And the universal language for constructing and talking to databases is called SQL, which stands for Structured Query Language.
Now, SQL isn't just one tool. It's more like a whole toolkit. Its commands are organized into different groups for different jobs. For our purposes, we're just going to look at the two big ones. You've got DDL, that's the construction crew that builds the database structure, and then you've got DML, that's the team that furnishes and manages all the data inside.
So let's meet the construction crew. DDL, or Data Definition Language. These are the heavy-duty commands that actually define the database itself. The create command? That's like laying the foundation and putting up the walls for a new table. Alter lets you modify that structure. Add a window and knock down a wall. And drop? Well, that's the demolition crew. It completely removes the table and everything in it, for good.
So, once the building is up, you need to manage what goes inside. And that's the job of DML, or Data Manipulation Language. Select is how you look at the data. Insert is like bringing in new furniture. You're adding a new row of information. Update lets you change what's already there, and delete lets you take out a specific piece of data without having to tear down the whole room.
So let's just step back for a second and look at this journey. We started with TechTrade's total paper nightmare. But by following this deliberate, careful design process, we've basically architected a clean, efficient, and really powerful digital solution.
This slide really sums up the whole journey perfectly. We started by figuring out the problem, then we sketched a big picture blueprint with that ERD. We refined that sketch into a detailed floor plan, the relational model, assigned unique keys to every part of the structure, and finally, we brought in our SQL toolkit to build and manage the entire thing.
And this is so much bigger than just one company. This whole methodical process, from a simple idea all the way to functional code, this is the invisible engine running underneath almost every digital service you rely on every single day. It's what brings order to all that potential chaos of information.
So, we've pulled back the curtain on the hidden architecture of data. We've seen how a simple idea can be transformed into a powerful, organized system. The only question left is, now that you can see the blueprint, what will you build?